Hello, everyone, and welcome to Learnable Computer Science. Today, we'll be going through the best programming practices for, in general, not only Python, but for all programming languages that you may encounter. So let's get into it. So first of all, for each slide, I'm gonna have a different topic. So if you already know this, you can skip ahead and you can look at that one. And so it's mostly going to be like me telling about what are the best programming practices. And with that, you can implement that inside of your code for all future use. And everything I'm going to say in this class is very, very important, as this is what professional programmers do. So getting a good grasp on all of these topics is very, very crucial and is definitely asked inside of your future CS courses. Okay, first one is comments and naming. Hopefully you already started doing this, but I just wanted to keep it here just for like all of the just for all the notes to be at once. So this is extremely important in future computer science courses. There'll be specific grades for how good your comments are and how good your variables are. So this is very important to grasp early on. And they're actually worth a good portion of your project grade. And comments are like, it allows other people and yourself to understand the code's purpose and description. It has no effect on your actual code. But the thing is, there are times when you write some code, you 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 actually go somewhere and then you come back and you have no idea what you've written. And over there, having comments is an amazing thing to do if you think that you're going to forget it later, because it can help you and other people who read your code more clarity on what exactly is happening. And naming is also very important, because like even though it may seem like a very small thing, it can go a very far away. Naming also allows you to understand the code that you've written. So comments and a good naming will result in a better overall code quality that will allow you to understand what is happening, which is super important. This is one of the easiest ones to implement. So I'll definitely just start as soon as possible, as we already kind of been doing this. So hopefully you have a little practice with this. Okay, planning and design. We have not really dug deep into this as much as the comments and naming, but this is also very important. So before you write code, you should have a plan of what you want to accomplish, and then like you'll have hours, days, or even weeks depending on the project. For example, right, create a Google Doc with the name of the project, provide an overview on the project you want to create, organize classes and functions, create a list of bare minimums to satisfy your MVP, and make an additional features that you want to add for future. This is really important. It may seem like this is completely unnecessary for us at this current skill level, but when you start getting really advanced, right? When you're writing like 50 classes or like 70 classes, you do not know what each class does. You cannot comprehend all of those classes inside of your brain. So if you can put all of them inside of like a document, and you can organize them to see what each one exactly does, will help you so much when you start coding. This may seem like such a big waste of time in the beginning, and you just want to get started coding. Bam, bam, bam. Oh, coding is super fun, right? You just want to keep on going. But there are many times when you code early and you get stuck for a lot of time, and the people who have made a planning document go ahead of them because they've already planned what exactly they need to do, so their chance of encountering errors is much less. So which is why I highly recommend making a planning document. And you could also make like a task worksheet as well, where basically you plan out at what days each feature should be done, and then from there you can do it. But I'll explain more of that later in the slides. There's also a thing called MVP. You may have saw in the previous slide I said satisfied MVP. You're like, well, what is that? So it basically means minimum viable product, or basically the bare bones of the product that you want to make. For example, if you want to make an open world game, is to make the character move around in a virtual setting. Like just to make the character move around with some background. That is your MVP. Or the MVP of a sleep tracking app is just to track the sleep and nothing else. Because a lot of apps here have a ton of features, right? Like the health app has a ton of features, but you mainly need it just for the beats per minute, just for tracking the beats per minute, or just by tracking the steps. So that's when it's very, very important. Those two features are the MVP, and everything else is just additional features. So the MVP is just satisfying those major features in order to get something out. So when you're assigned a product, building an MVP is crucial, as it is the defining point on whether you actually finish the project or not, which may seem kind of weird, but the thing is, if you have a big enough project and you don't scale it down, you may seem overwhelmed and you start coding and you just give up because it's too much work. So it's super important that you start making a draft for the MVP, and then you finish the MVP, and then you add additional features. Okay. Next is pseudocoding and trace statements. Again, we did not really dive into this as well, but I'll just explain it and also give an example on the next slide. So pseudocoding is a process of writing your code in comments before you actually code with syntax. So you may be asking, why is that really helpful? It's helpful in determining what you will need to code. For example, if you need to have like a function, like a big function on what you need to do, instead of writing the while loop or like if loop with all like the complex syntax, you can just say if this or this, like with English, and then you say if this or this, do this, right? Like, and also for like the function, you could just make a function with, and then you just put in like the comments underneath. So it allows you to write, it forces you to plan your project in a much deeper way. So that's why it's super helpful. So this may seem excessive, but it's crucial for big projects. And me, myself, like, I remember I did pseudocoding for one project and it was so much work. But if it weren't for the pseudocoding, that project would have taken me a lot of time. So I would highly, highly recommend pseudocoding, but only if you don't feel confident. If you feel confident, then it's not exactly necessary. Then I would definitely make a planning document with everything that you need to have. But if you're not sure at all, first pseudocode, then make a planning document and then start coding is what I recommend. Because even if I say to do pseudocoding, I don't think many people will do that just because of the sheer amount of work. So let's make a deal, right? So if you're not feeling confident with coding, then pseudocode and then make a planning document. But if you are kind of confident, just make a planning document. There's no need to do pseudocoding. Hopefully that's a little agreeable. Okay, so next is trace statements. So it's basically including print statements to see if Python is actually executing a line of code. Should be pretty simple enough. So basically, if you're having an error with the function like not appearing on the console for some reason, like the contents of the function not appearing on the console, you could, or no, sorry, if you have a function which is not executing correctly because it's skipping some more lines, you think, so just including a print statement there and just making sure that it actually runs the print statement. If it runs a print statement, is running correctly, so that means there's an error with the logic that you have. Or if it's not running correct, or if it's not printing out, then you have some error with where it's being called. So trace statements are very useful if you have like a multi-dimensional program where you kind of need to see where exactly you have an error, because just the sheer amount of classes and functions that you have. Very, very highly recommend. Actually, no, you will have to use trace statements at some point of time, I can guarantee you. So I would highly recommend just start getting used to it now. Okay, so this is an example of pseudocoding and trace statements. So pseudocoding, this is a very, very simple example. You will not pseudocode this example, but I'm just but I'm just giving you an example of what I'm talking about. So first define the function and then return the price. So this is the pseudocode in comments, and just translate that into actual code. Like for example, the self syntax is not there, right? Set price is not there, right? So this is just super, super simple. And then just kind of convert that into syntax. And here you just put trace statements like print trace and then print trace 2. So you want to see whether the constructor is running. You just put the trace statement here to make sure that if it prints out, then this constructor is running. If it's not printing out, then this constructor is not running. So that's why there's some error with that. And and then if you want to get the title, but for some reason that title's not returning where you want to, just putting the print statement in the beginning just to make sure that it's actually returning the title is super, super useful. Okay. And finally, we have deadlines. So this is the best way to get work done. And you will be pressuring yourself to complete your work and not work last minute. And procrastination never works in computer science. Trust me, I tried. Many people tried. It does not work because you do not know what errors you'll face, right? So it's super you cannot procrastinate in computer science. And don't set too little or too many deadlines. It should be around one deadline per week is a very good sort of middle ground. And you can add tasks. So deadlines and tasks are different. Deadlines are like you finish the MVP or you finish the first design of the app. Well, tasks is like you finish this feature or you finish this feature. Tasks can be finished once every day. Day is fine. But yeah, please deadlines are the best way to get work done. So if you put a deadline to yourself on I need to finish this by this date, you'll be more likely to work and you'll be more likely to finish on time or close to the time that you want to finish rather than not putting a deadline. So that's basically it. So next class is the final class where we have like an entire review of all the content that we have reviewed, and we also have a final test. So, but things we won't have any homework though. So if you haven't finished any of the previous homeworks, please be sure to finish that. But other than that, I'll see you in our last class. You all did amazing in this course. I'm so proud of you all. You guys have truly learned so much about computer science, not just the not just the computer science skills, but also the programming skills as well. Like putting your brain into it, kind of like analyzing what this means, even though not being explicitly taught that. Also to look up how to do this thing if you have not been shown before, because people won't be there right next to you all the time. You have to figure things out yourself, and you have to get it done no matter what. So those kind of skills are very, very crucial as we go on to like the next stages of computer science, like an internship or job or college or whatever. So that's very, very helpful. It will guide you a long way. So keep being great, keep doing computer science, and I'll see you later. Bye-bye.